later. So basically, you can rerun the code, can reproduce the same figure. So that is good features. So for some packages, some it's not very stable. It can maintain, it can change day by day, right? Because the code you might written months ago or years ago cannot be reproduced, cannot be run after some time. So that may not be good. But for R visualization, almost all the dominant packages are actually very stable. So that is very good for reproducibility purpose. So that is very important if you want to rerun the code sometime later after you have written the code. And of course, a lot of packages and functions can be run provided by R. So that provide a lot of functions, a lot of options to visualize your data. So that is a good feature. The output of the R can be exported as a different figure format, such as the PostScript, PDF, JPG, and PNG. So I think that is a good feature provided by R. So we briefly talk about the history of graphics of R. So the development of R visualization actually have two stages. One stage is come with the development of R language. This is basically low-level capability for R. This is called basic graphics. I think Dr. Chizhang probably mentioned in last week about how to have some simple plot to use the basic graphics. And when probably in 2005, some researchers developed some high-level packages for enhance the visualization. So these packages, the two famous packages, one is called Lattice, another is called ggplot. They are actually very integrated high-level function for R visualization. So basically, can just write several lines of code, but you can actually get very opinion figures. Compared with the basic graphics, usually you need to write dozens or even hundreds of code to have the similar figures generated by high-level packages. So that is a good feature for the ggplot and the lattice figures. I think we'll talk about that later. Okay, in this lecture, I think today's lecture, we mainly focus on the basic graphics because this is the basic and this is fundamental. So you can control everything, every step in your programming. For high-level packages for visualization, sometimes it's highly integrated. You cannot control every aspect. So some for low-level graphics and high-level graphics, they all have their pros and cons. So for high-level programming, it's like user-friendly, right? Because you just write several lines of code can get very good figures. For low-level, the good feature is it can control every step, but sometimes it's very tedious to produce one figure. So in this lecture, we focus on the low-level R visualization language in this lecture. For basic graphics, for R visualization is oldest but most commonly used. So this is on a model of pen on paper. So basically, you can control every step, just like you draw something on the paper. You can modify, erase, or delete whatever has been drawn, right? So this is everything's under control. It's all very fast because it is come with the R programming language, and a lot of documentations that you can just Google online, and you can get all the support. So you have some troubles, you can just Google the error, Google the trouble, and other people, most people will sometimes often encounter the same difficulty. So you can just find their solution, and it can help solve your problem. And when the basic R graphics have been developed, some researchers have been developed more advanced packages. One is called a Lattice Package. So it's easily to create a conditional process with the automatic creation axis, legends, and other annotations. And an improvement over basic R graphics because it's more automatically instead of control every detailed steps. Most of the things is integrated. And a more advanced package is called ggplot to develop in 2005. And it's also implement some grammars or graphics. So it's a general thing for data visualization, which break up graphics into several semantic components, such as scale and layers. It is also can be served right now is a good more and more popular as a replacement for basic graphics thing. I think right now most dominant packages for visualization is ggplot2. So in this lecture, we briefly talk about the R graphics and the basic R graphics component. So they usually have several most important functions, such as points. So basically, you add points to the plot, lines, you add lines to the plot, arrows, you add arrows to the plot, text, basically you add text to the plot, blind, so you add the slope and intercept a line into the plot. So polygon, basically they draw a polygon. A legend, you add a legend to the plot. This is title, so it's add a title to the plot. So you have axis, has text and the segment, so on and so forth. So this is also very important component functions of R basics. And also have others more high level R functions such as plot, right? So this is just a plot, the relationship between variable x versus y. So bar plot is the plot the variables of x. So x basically think about this as a vector consists of many numbers. So the same is box plot for the get box plot for the x. You can also get a histogram for x and a pie chart for x and have a dot chart for x. So QQ norm or QQ9, this is more like a more statistics based visualization. So pairs and is for like a scatter plot. You can also get a strip point and a coplot. So we'll talk about those, have some examples for this plot to show how basics can actually work. And also some detailed function like parameters you passed into these functions can control some details of the figure you generated. You can add a new plot on the top of the other. So you can turn on or turn off the axis. So also you can set some numbers on your y-axis and the x-axis. So you can add some title to your figures. And you can have some subtitle to your figures. And also you can control the type of the points, control the type of the lines, and control how you collected the points, and how you overlaid the lines, and so on and so forth. So basically, this is all parameters you can add into the plot functions. Also, then many other things, you can control the margins, control the color, control the size of your point or type of your point, control the size of your lines, and control the font of your control the font size, and control like a different styles of the lines, and so on and so forth. Actually, so basically you can control almost everything in your basics. And also when you plot the figure in your RStudio, you can save your figures into different format. Some is PDF, PNG, or JPEG, BPM, PostScript, and Windows Magnifier. So basically you can save your files in somewhere. Then you can insert your file into insert your generated figures to your Word file. Okay. So right now I think we'll go to some detailed examples and to see how actually these functions work. And I will have some hands-on to interactive with the lecture content. Okay. So the first you can see a figure right here. This is actually looks very nice figure. This have a two box, right? Have an internal box. So basically this is a red box. Have an outside box. This is a blue box. So both boxes are actually a dash line, right? So within the internal box, we have some red sentences such as plot stuff here. And around the red box, so we have some other texts such as west margin, loss margin, eastern margin, and south margin, right? And we also have some labels X, Y, and a title example plot here. So how can we get this plot? So in this plot, basically you can see, okay, I can control almost everything. I can control where I should draw the box, right? I can control where I can draw this text in different direction, horizontally or vertically. So I also can control the lines, right? Which should be a solid line or dashed line. I also can control the color of different text, right? So how can we do that? Then we go through the code, so we can run by one. For those who already install your RStudio, so that'd be good, because after the lecture, we'll share the code and also the lecture. So you can play on your own computer to see, okay, if I change something, what will happen, right? So that would be helpful to learn how to use R for programming. So first, I just run the code line by line. So in RStudio, basically you can select one line, right? And there's a run button here. You can click run. Okay, I create something, so what happens? So basically, I create an empty plot here. So with X label X and Y label Y, right? So I set axis as false, so that we didn't see anything about the axis. However, if I change it into true, so what will happen? So okay, I can see all this axis, right? But right now, for this purpose, we don't want the axis to be happen, so that is why we change it to false. So once we draw this axis, so actually it exists, but we cannot see that. We want to draw the grids. So the grids, then we select this line again, and we clicked. So we can see the grids right here, right? Because this is actually the grid color, so we cannot see that very clearly. But if we change it to another color, COL means color, if we click that, we can see, okay, this is tend to be red, right? So this is like horizontally from 0 to 10 with like step 2. So basically we can create from 0 to 10 with step 2. So this means 0, 2, 4, 6, 5, 8, and 10, right? With separate steps. So for each step, we can create a horizontal line here. So that is good. So then we want to create another grid basically on the vertical line, right? So how can we do that? We do the same thing. So the only thing we change, so basically we change the H to V, which means the vertical. Then we click that again. Okay, so we can see the grid, right? So this is the gives the horizontal vertically from the step from 0 to 10. Okay, so I think that is we can create a vertical here. This is actually reproduces the internal part, right? We can see some greens grid here. But right now, I just don't want to, for visualization purpose, I want to turn this to red. So let's turn it to black. Okay, still grid side. Right now, you can see the two grid line, the grid line here. Then we want to put some texts in the plot region. That is, it's fine for like this should see something like a plot stuff here. So right now, we want to plot some stuff here, right? So this is a function called text. It basically asks you to put some text in your figure. COL, which is means in short for color, right? So this is a straightforward. CEX, with these parameters indicate how large the font I want to put into the text. Right now, I set a font at 1.5. Definitely, what you can change that. Then we run this function. Select this line again, click and click run. Okay, right now you see right? It is cool, right? You can see the plot stuff here. So what about if I want to change the font size? I just increase the number from 1.2 to 3. Then click again. You can see that, right? The font change dramatically. So this is depending on you how to change the font size. You can manually play with all the numbers and the parameters to do that. Also, if you want to do a different color, you don't want the red color, you want the blue color, what do you want to do? You change this to red to blue and click, right? So you get some blue color here. Okay. So that is good because we can put some okay, we start from the beginning and then we have these figures again. Then we want to draw the boundary blocks, right? Because right now, what we have right now is for the internal grid and also have an internal this text plot stuff here. We still want to get additional things such as the around this red dash box and also this blue dash box and all the texts between the white dash, blue dash box and the red dash box. So how can we do that? Let's go step by step. So first we want to create a box, right? Because we have a red box just around the grid we just plot. So we have a function called box plot, color is red, and the style, LT style, which means the style for the line, is the dotted style. So let's do that. Okay, cool, right? So basically we add a box outside of the grid we just created. So we set the line store. This is dotted. So basically the line actually is dotted. Of course, I think you can set it to solid. Let's try that. Okay, right. You can see that. If you don't want to the dashed line, you want to make it to the solid line, you can just change the value of the parameters of LTY into the solid. So we'll go back to the dashed line. And also we have another box, right, which is the inner box. So basically we have the blue box, right? So we add some blue box against the out front. So that actually we reproduce what is the big figure, right? We have the inner box, which is a red dash box, and we have a big box, which is a blue dash box. So right now I have two boxes, right? So that is cool. So we basically have all the box. Then how can we put the text into the margins? We're still missing something, right? We don't have the margins such as the several margin, western margin, north margin, eastern margin, and southern margin. We didn't have those texts. So also we want to put those texts into the margins between the inner red box, and outside the blue box, right? So that is what we want to do at this point. Then what we can do for that, there's a function called mtext. So mtext, so basically you can add the texts into the margins. Okay, so how can we do that? So still the same thing, we select. Okay. So in these functions, we see this is the text we want to place, right? This is into the different direction we want to put. So we have 1, 2, 3, 4, which means north, south, east, and west, so on and so forth. So this is what is mean for 1, 2, 3, 4, 5. CEX basically is a font size. So this is for CEX. So 9 here. So basically, 9 here didn't have too much meaning. We can ignore about that. So this is the color for blue, green, orange, and purple. So we can see this different color, right? Blue, orange, blue, green. This is orange. This is purple, right? So let's just run this line by line to see what will happen. We run the source margin. Click here. Okay, great. We can see the source margin here, right? So source margin, source is in the function directly at 1, and which is exactly the same thing as the big figure. And also the color is blue, right? So the color is blue, and the font size is 0.2. Of course, you can make it bigger at 0.2. Can make it bigger as 0.5, right? So that is we can definitely do about that. And we want to set another western margin. So western margin, what is the direction for western margin? Is on the west, right? So west here is indicated as 2. So and the color is green. We run this again. Okay, we can get a western margin. So on and so forth. So we can get a north margin and east margin, right? We can select the 2 lines and we'll click run and we'll get the 2 things. So we still miss one title, right? Because in the figure you want to have a title to indicate what is the message the figure want to convey. So that is why we want to add a figure here. Okay, we click that and we can get our example plot. So this is basically exactly reproduce what we have for this figure, right? So that is cool. That basically this is you can see that for our basic visualization, you can control every step. You can control every details, the color, the font size, where you want to put the figure, right? Where you want to put the text. So basically, you can control every step, every detail is under control, just like you use a pen to draw a figure on the paper. So this is for basic R programming. So we want to do something more complicated, right? So that is, for example, we want to add some data into the figure. Instead, right now we only have text and only have margins. But in some cases, we want to add some data to the figures. How can we do that? So we still use the same code we just run, right? We rerun the code again. Okay, so this is the figure we previously run. Right now, we want to add something different, add some data into the figure. So the code that is the difference, the additional one line of code is called the points. So clearly we want to draw some points to the figure, right? Because the function is called points. So 0 to 10 basically is a number from 0 to 10 here. Okay, so 1, 0, 1, 2, 3, 4, 5 until 10. This is the vector containing about 11 numbers. So in R, the shortest for 0 to 10 is written in this way because you don't have to write every number as so basically it's a default with step 1, so we can get numbers from 0 to 10. So this is for x for one vector. Another vector is still 0 to 10, right? Because you want to plot, you want to have a dot plot, you have 2 dimensions from the x-axis and the y-axis, right? So basically you have 0 to 10 versus 0 to 10. And the PCH 20, basically this is indicates the style of the point. So style of point is 20, but we can change the number, have different style of the point. The color of the point is red, but the background of the point is black. So let's do that to see what will happen if we want to add the line of code to these existing figures. We still select the line and we'll click run. Okay, which is cool, right? So basically we can actually visualize the data into the figures. So that is very important for our visualization. We don't want to just visualize the text. We want to put the data into the figures for this data science and the data analysis perspective. So here we can see that this is diagonal on the right? Because we plot the correlation between 11 numbers to the same 11 numbers, right? So if we want to change a different number, let's say we don't want to, the axis is still 0 to 10, but for y-axis, I want to change something different. I don't want to, this is between from 0 to 10. I want to change it to be, for example, 3 to 14 or 3 to 13, right? I want to do something different. And also, I don't want the color to be red. I want the color to be blue. So whatever happen? Okay, right. So we have something different because the x-axis is the same, but we change the y-axis. So that will cause the change of the figures. Is basically the shift upward a little bit. So that is change the code back. So that is a nice feature of the plot. So basically, we can also add the data into the existing figure. That's a good feature. Okay, so there's something more, right? So right now we add a text as okay within between these 2 margins. So what about if we want to add additional text outside of the blue margin, right? Compare this figure from the figure we just drawn, right? Clearly we can see that we can add additional text that's outside of the blue margin, right? So how can we do that? So we can use most of the same code we just wrote. Let's redo this again. But pay attention that we add some functions called par outside margin. So which is the indicator vector 2, 2, 2, 2. This is allow you additional space in the outside margin, which is for us to put the text on. If we didn't have this, you cannot put the text into the outside margin. So let's do that, rerun the code what we have. So this is basically reproduce what we have in the first figure. Right now we want to add the external margin outside the blue box. So how can we do that? So we'll still use the m text, right? Also, let's run the code. But right now we pay attention that there's an additional function called auto here, indicated true, or here indicated true. If we didn't have that, you cannot plot the text in the outside margin. Let's do that. Cool, right? So basically you can see the out margin east. And what about orange? Let's do that again. Okay, so we have additional like outer margin north, right? And we have outer margin north and outer margin, this is east, right? Outer margin east. So this is the indicator purple. So that is cool, but be sure you add the function is cut out, otherwise it's still overlapping with the text as you plot inside. Okay, so that's So this is basically a plot. This is a one panel, right? So basically, you just have one figure in one paper, one figure in one panel. Sometimes we want to put multiple figures together in one big panel. So how can we do that? I was thinking the late lectures probably other instructor will talk about the functions of R, but right now I just want to briefly touch base about that and give you a sense about how R functions can be used to efficiently produce different kind of figures in a big panel. And here we basically write a simple R function. It is called a myplot. So myplot is a function. So basically can take different parameters into the plot functions. And the good thing for function is for reproducibility. So basically you can change several parameters. So you can generate different figures. You don't have to rewrite the code from the very beginning and copy and paste everything, right? So here, basically we create a panel figure or 2x2 big figure, 2x2 panel here. Previously we have 1x1, right? Because of just one figure. Right now I want to do more. I want to do 2x2 figure here. For each sub panel here, I want to draw a different figure, different from one versus the other. And then we call the functions 4 times, right? Plot 1, plot 2, plot 3, and plot 4. And we'll pass 2 different parameters, a different size into other functions. So what is the size 1 and the size 2 mean? If we go into the size of the functions, you can say that size 2 means the font size of the text, right? And the size 1, what does size 1 mean? Size 1 here means the size of the text as well, right? So 1 is a text in the middle, and that's you have 2 texts of the font size. Basically, it's a plot and versus a figure. So let's do this to run the code to see what will happen if we run the code. So this is a function, right? If we run function, so nothing happens until we call the functions. So basically, this function helps us to like plot, reproduce different kind of figures. Then we call this is called the design. This is a 2x2 panels. So we need to call this, otherwise the figures will jump into 1 by 1. So let's run this code. Okay, nothing happens because it happens in the back end. It didn't happen in the front end until we draw this plot. So we call these functions. Okay, you can see that something happens, right? So after we design the figures into 2x2, and we draw the first figures, then we can see, okay, the first figure happens, right? The font size for plot 1 and figures is 1 and 1, right? We see the 2 font, 2 texts in the data plot. So how about we draw this again, right? Plot 2, and the font size 2x2, so we expected the plot 2, the font size of plot 2, and the figures were larger than the first figure. We select the code and we run again. Cool, right? You can see that again because why is this plot 2? The font size of plot 2 is bigger than plot 1. The font size of figure is bigger than the first plot because we set the font size in the 2 texts larger than the first one, right? We pass the information to the parameters because we plot exactly the same plot. We don't want to paste and copy paste again and again. We wrap up in this function. So to help us to save some copy paste work when we draw these figures. Then we want to make the font even larger to 3 and 3. Then run again. Okay, we can see plot 3 is even larger and the figure is even larger, right? So last we want to make the font smaller than the first figure. Then go through that. We found the plot 4 and the figure is smaller, right? So that is pretty cool, right? So how about if we want to export the figure into Pda Pdf or Png format? So how can you do that? So basically, you can see that button here called export, right? You click that, you can see, okay, I can save into an image. So basically, you can save mostly save in the Png format. Okay, I can save a PDF, right? Right now, I can just save into an image. So what will happen? It asks you to save in a directory, right? Just as we play with Windows systems. Then we go to the desktop. I want to save into the desktop. Okay, I click on save. The lane right now, I can see, okay, this is called a 4-panel plot, right? I can call this 4-panel plot, and I just click save. So let's go back to the escape into front, right? So I click again. Okay, right, this is a PNG format. So this is a draw. The figures actually draw from the RStudio, but so basically you can save into any places on your computer. Right? Then you can open the Word and you insert your figure into your Word and to prepare for your dossier or prepare for your essay or something, right? So that is practical. So this is another, how can you ask R to draw this like a panel plot? So we go to other more, that's more and a complicated plot. Right now we see we want to add more data into the figures because eventually you want to do data analysis, right? You want to add their data into your figures, not just a text, not just a plot. So here is we can see that, okay, I can draw something, the correlation between a WT and an MPG. This is the data set I want to show you. It's called the MT car. Okay, you can see this is called the data set called the MT cars. Hopefully everybody can see that. So this is the data actually. The row actually is a different car, right? The column is MPG. I guess it's manager per gallon, and have different parameters, right? This is WT. I think it's called weight, different weight, and they have a different parameters for different brands of cars. So you want to draw some relationship between like the weight of the car and the MPG of the car. So intuitively, the lighter the car is, the higher the MPG is, right? So we want to draw, okay, whether we have some inverse relationship between the weight of your car and the MPG of the car. So how can we do that? How can we investigate our hypothesis into a figure? So we want to do some like visualization of the car, right? So there's a color we can do the plot. Use MPG in the data set versus the weight, right? So the column of the data set is called MPG, and another column is called the WT. This is weight. We want to draw the relationship between these two variables, and we use this sign to indicate the relationship. The data set is called MD cars, right? So we just put a data set here. I guess we can also specify, okay, this is the data to MT cars. The title of the figure is called the sample thing plot. So we can just do the thing. Let's see what will happen. Okay, cool, right? We can draw this figure. We can draw a relationship between MPG and weight. Clearly, the heavier your car is, the lower the MPG is, right? Because the heavier your car is, the more gasoline it will consume. So this is as we expected, right? So this have kind of inverse relationship. But right now we want to add more like colors. We want to get something different. We add some colors. We want to get something different point size, right? Different font size into your figures. How can we do that? Then we pass different parameters into your plot functions. In addition to the default of the plot functions, we add something new, such as colors, right? This is the the different style of your point. This is your font size of your title. Let's run this code to see what will happen. Okay, you can see something different, right? Because we'll change the color from the dot points to the red, right? And also we change the title size, font size sample plot from one default is 1 to 3. So we can see some big font size and also see the dot from the hollow into this red. So that is a difference we didn't make. So that is cool. We can do some data analysis to visualize actually the relationship between different parameters, different variables into your data plot. We can also do something different. I guess that is more complicated. So basically, we can put multiple figures into one panel, just like what we did. But here we want to do some data analysis, data visualization, right? So how can we do that? Let's do it in this way. We still set this is we want to design this panel at first, right? Because this is a 1x2 figure. Remember, right? This is 1x2 figure here. Because we have 2 columns, 1 row, right? This is 1x2. So that is why we specify here the parameter here mflow equals 1/2. This is the fixed parameters for R programming. Okay, then we plot the two subfigures here. The first plot is plot the relationship between MPG versus weight, right? The second plot is still plot MPG versus weight. So basically, we use the same data visualization, the same relationship of the two variables. But what's the difference is like we use different point style. The point style for the first figure is PCH4. The point style for the second figure is PCH23. Also, the colors is also different between the first figure and the second figure. In the first figure, the color for the dot point is red. In the second figure actually it is blue, right? So this is the difference between the two subfigures. So let's run the code to see how can we get the plot. We still select the lines of the code we want to run. You can select 1/9, but of course you can select multiple lines. You can run all this code together. You don't have to just choose one line by line, right? So that is a good feature for RStudio. For those who didn't install RStudio, I would suggest you try to install RStudio after the lecture, because this is important. After the lecture, you can play with all the code and read the lecture notes by yourself. That is a good way to learn programming. The good way to learn programming is not listen to lecture, it's actually you hands-on to practice by yourself, okay? So you select all the lines of the code, you can click run again. So that is cool, right? So we can generate the two figures. The two figures actually convey the same message. So basically plot the relationship between MPG versus weight of the cars, different brands of cars. The difference between the two figures, one is the point style, right? Point style for the first figure is 4, for the second figure is 23. So that is say you have a different point style. The second difference is like the colors, right? In your first figure, the color is red. In your second figure, the color is blue, right? So that case, you can see, okay, the point color is some kind of different. So that is for this figure. Okay, we can put the figure into subfigures into big figures. We can also do additional things. Okay, we not only want to do this dot plot, we can also do the line plot. Sometimes I just don't want the dot plot. I want to plot the line, right? So how can we do that? Let's say, okay, what has this figure? We draw 3 different lines. The 3 different lines means 3 different things in your data matrix. Let's go back to the data matrix. So this is data we have, right? So we have this is a different brand of cars. We have different columns to different characteristics of the cars. And here we want to plot different things. So the first thing is MPG. The second thing is called a drat. The first thing is called Q second. That's right. I want to plot the 3 columns into this data matrix. So how can we do that? So basically, this is 1/1 figure, right? So in this we set 1/1 instead of 1/2. We just saw. So just set parameters here. Okay, so the y-lane, so basically which means the range of the y-axis. X-lane, which is means the range of the y-axis, x-axis. Then we can do the same plot to set the limitation for the x-axis and the y-axis. We can specify the type of the line called L, right? And we can add additional lines into the plot. So plot is a basic functions to help generate the big figure, big framework. And we can add 2 lines into the big figures. After that, we can add some legend, right? Because we want to specify which line is which. If we didn't add a legend, we didn't know which line means MPG, which line means drat, which line means QSet, right? So we need to add some legend here. Finally, we add one title to indicate what is the main message the figure want to convey, right? Okay, so let's go back to the code and let's run it to say what do we have. We first want to run the first 4 lines of code. Let's click that. So cool, right? So what does this figure mean? This figure basically means that we draw the MPG of the cars. So there's nothing else, right? So this is just a figure to draw the MPG of the cars. So we want to add additional information to the figures. For example, we want to add drat. into the figure. So how can we do that? Let's run this 9 figure here. We add 1 9 into this figure. We click that. Okay, you can see that, right? There's a green line to be added into the figure because we call the 9th function. Another thing is, right, this is an empty class, is a data matrix, right? If we want to get 1 column of the data matrix, we use a dot sign here to get 1 column of the matrix. So, right, so this is to get the column of the matrix, or something like this. And we want to draw another line QSEC into this data matrix. Then we click this line again, clicked. Okay, we add a third line into the figure again, right? So right now we have all the lines, but we're still missing the legend. Right now we didn't know which line is dot, which line is QSET, which line is MPG. So how can we do that? There's a function called in Arc legend, right? You place the legend into the top right. And for each legend, the name is the MPG, dot, and QSET, right? Because the colors we draw for MPG is black, dot is green, QSET is red, we indicate the colors in the same way, corresponding color black, green, and red. And the PCH, which means we use -9 to indicate the legend. So let's run the legend to see what will happen. Okay, right now you can see that, right? We add the legend to the figures. So the black, which means MPG, green means dot, and this is red is QSET, right? And we mentioned we want to add a title, right? MPG, dot, and QSET. So that is cool. So if we want to we also sometimes want to add some grids. So we can also add grids, right? Because if we add grids, you can see, okay, sometimes you can see some data point more clearly. So that is we can actually draw the 9 figures into one figure. So you can design different legend to replace different things in your data set. So that is cool. So we briefly talk about the pointer, different pointer type, right? Because we see different point, they actually specify different numbers. We need to refer the numbers to see, okay, which actually it means. Let's go back to the figures we drew before, just like this one. For this one, we have a different type of this point, right? But right now we specify the point as 4 and 23. Didn't know which one is which. 4 means which, and 23 is means, right? You need to go back to this reference to see, okay, 23 actually means this, and 4 actually means this, right? You can specify 4 and 23 or different kind of point style into your plot figure as parameters. So you can actually draw different point style. Let's go to a very funny example. So in this example, we can actually draw like a different point, okay, with some sort of kind of step. Let's draw this figure. So this is cool, right? So this is basically, we can draw every different style or every point actually in the existing R library, right? So 15 means this, 17 means this, 18 means this, so on and so forth. So basically can try the code to see what will happen if we want to just draw all the points or styles. And so in next step, so we also do something different. Right now, instead of draw like different lines, we want to draw different points into one figure, right? So also I want to add legend into the figures. So here, we still go back to the same data set. This is called empty class. So empty class will focus on this is for different engine, right? Different engine power. Sometimes we have 4, sometimes we have 6, sometimes we have 8. So this indicates the characteristic of car. We want to stratify the engines, the power engines into different groups. So we have a function called subset here. We stratify the big matrix into 4 groups, 4 engines, 6 engines, and 8 engines, so on and so forth. Right? We first subset the big matrix into 3 small matrix. Then we can do some like a plot again to see what happens. The first plot we made, okay, this is a plot, just plot nothing, right? We just plot a matrix, plot like a frame, right? So we only have axis, but we didn't have anything. So that is we select the type here. So which means they don't want to plot anything into existing plot. Then we want to add the points one by one. So you first want to inspect for the 4 engines cars, what the relationship between the MPG versus weight. So, okay, you can see the points here, right? So this is an indicator for the 4 engines. And you want to add the 6 engines, you click that again. Okay, we'll add additional points here. So how about the 8 engines here? Then it's here, right? So actually we can add different points, not only different lines into the same figure. And we add 10 by 10, one step by one step. Eventually we want to add the legend into the figures, right? So we didn't know which one is 4, which one is 6, which one is 8. So how can we do that? So we click the add the legend function here. Okay, we have legend here, right? We know which point will indicate 4, which point indicates 6, and which point indicates 8. So that is cool. So not only we can add multiple lines into the same figure, but also we can add multiple points into the same figure, different type of points into the same figure. So another example here is like, this is also very cool. So basically we can add a different type of lines into the same figure. This is also a relationship between MPG and weight. So this is a dot plot, right? This is a line plot. So this is kind of more like a bar plot. So this is kind of dot plot, but instead we collect the different dots by the lines. So let's do this to see how it happens. Because this is, okay, this is a 2 by 2 figure here. We indicate the parameters set 2 by 2. And in the first we plot is type of the P which means points. So let's do that. Okay, this is a point. P indicate the points, right? We only have the dot figures here. In the second figure, we want to plot the line figure indicated L. Okay, we have 9 figures here. In the third figure, this is more like a bar, like a histogram, right? So indicate H. So here we can see, okay, this is bar. In the fourth figure, we want to collect all the points by L. So this is the type called O. So click here, we can see, okay, all the dots are collected actually by the lines. So by specify the type of function here, a type of parameters here, we can indicate how the points actually draw. They draw separately out of the individual points, or they can draw as an indicator lines, right? Or can draw an individual as different bar. So this is another good features. Okay, eventually you can also add some legend or different points into the last figures. Okay, so here it's like say, okay, when we use the plot functions, there's many parameters. This type of parameters help us to draw the points actually in different style. Also, we can draw the font of the points right into different styles. So let's try another figure. So in this figure, basically we can draw the font into different style, right? We can have small dot, we can have a big medium-sized dot, we can have like a big size dots, right? So here we just draw, set the CEX as a parameter to control the size of the points you want to draw in the figure to 1, 1.5, 2, 3.5. So you can see the dots grow larger and larger. Okay. So that is actually a good feature of how you draw on different points, different size points into one figure. And not only for the points figures, actually that's called a scatter plot. So scatter plot is a good function called pairs. So pairs basically can pair, actually do the scatter plot for the pairwise columns of your data set you have. Just to recall for the cars, so the data set will have actually multiple columns, right? So for the multiple columns here, we can draw the pairwise correlation of multiple columns. And here we focus on first column and third column to the sixth column. So basically we focus on MPG and display until the 6th, right? Until the Q set. And right, we want to draw the pairwise correlation between MPG and versus the others. So how can we do that? So basically the function actually carry pairs. So the font size we set to 0.4, and the point style we set to 21. And the title, the background is light blue, the main is pairs of the 5 variables. We can select the code and run. Okay, this is actually cool, right? So basically we can plot the dot correlations between different columns actually in this style. This is symmetric, right? So basically you can just focus on the up triangular. So this is for lower triangular is the same as up triangular. So basically we can plot the correlation among the variables. So for R plot, actually that's other style. It's called the CO plot. CO plot is a conditional plot that displays relationship between continuous variable on per category basis. So this implies that there's at least one continuous variable be plotted in different group or categories. So basically for CO plot, we can actually plot the continuous variable stratified by different group. So in this figure, that actually we can factorize one into the kind into automatically kind into manually kind into different two groups. Then we can plot for automatically kind, what is the relationship between MPG and weight? And for manually kind, what is the relationship between MPG and weight, right? So in this figure, you can see, okay, for automatically kind, the relationship between MPG and weight is like in this way. But for manually kind, this is different, right? So this is kind of this is called for co-plot. Let's do using this way. It's stratified by the auto car and the manual car. So let's do this to see. Let's run the code to see what will happen if we want to draw this way. We'll have two lines of code. First, we want to make sure the auto and the manual actually is a vector. Is a factor. We create a factor in this way, right? By run the factor functions. Then we pass the factors into the parameters into the CUPOT, OT, these functions. Let's run this into now code to see what happens. Okay, that is cool, right? Right now, we instead of investigate the MPG and weight by all the cars, we actually stratify by the auto cars and the manual cars into this way. Correctly, it seems like for manual cars, for both stratification, there's some strong negative correlations between MPG and weight. So we can also stratify by multiple things. So here we stratify not only by the type of the cars, whether this is auto car, this is the manual car, also stratified by the power of the engine, whether this is a 4-cylinder or whether this is a 6-cylinder or this is a 8-cylinder. So this is kind of we can stratify by the two interaction of these two factors. Let's run this code to see what happens. Right now you can see, right? Okay, we have not only have an indication on the x-axis, we also have an indication on the y-axis. Into y-axis, the cars are stratified by auto and manual, and in the x-axis, the cars stratified by the power of the engine, whether it's 4-cylinder, 6-cylinder, or 8-cylinder, right? So we can see the interaction of the two factors to see what is the relationship between MPG and weight. So this is a very good feature. So you want to investigate multiple interaction of the factors into your figures. Yeah, of course, we can add some nice things, not only add some lines, add some dots into your figures to make it look better. We can write a function here called myCoplot. MyCoplot is basically add some points style, right? And add some line style into your figures. So let's, if you want to call this is your own write functions, you pass your function into a parameter called panel here. So we write one function, we run function, nothing happens until we call the functions. And we run the coplot, we pass the function into the parameter as a parameter into the function, so we run that. Okay, right now you can see what's the difference between this figure and the Pairwise figure is like we add some lines, right? We add some dots into each panel of the figure because we write one myCoplot function is actually passed into the coplot functions here. We can do additional. The second thing we want to jumping out into want to see the colors, right? Because Pairwise you can see different colors, right? We want to see okay how many colors we in R's, and we want to say sometimes we want to specify different color. So colors is actually functions in R, and we actually for R here you can see we have more than 600 different kind of colors. So sometimes we want to specify the colors of lines, colors of points. We can go into the 600 color to pick up one that is we want to choose, right? So that is good for the color. And also here for this example, which the figures we just draw, right? So basically we can select different colors into this figure. Besides colors, there's two things we can specify colors. One is called colors. So let's see. I have different. So I think second thing is called a rainbow. So rainbow is the second way for us to select the color. Let's say rainbow, right? For rainbow, right, the color is not that straightforward because it's actually encoded in different ways. But for colors, actually, this is straightforward. Basically, have some some kind of word meanings you can choose from one by the other. So we can just choose colors selected by rainbows. For mine, I think probably you can choose colors because more straightforward. Here we also want to draw a plot, right? Just to reproduce what we have seen before. I choose these three different colors by using rainbow, and we plot a line by line.
Dr. Chen?
Yes.
Students have a guest speaker on science communication.
Okay, yeah, I think I noticed that the 10 is up. Yeah, I just noticed. Thank you for reminding me.
Dr. Sullivan is his name. Thank you so much for your time and for showing us all of these different capabilities that R can do. I can say, even if I can't necessarily immediately go program these things, I've learned a ton that you can do all this, and I'm beginning to get the idea of it. So thank you so much for your time. Students, you're doing a great job saying thank you or applauding.
Thank you.
The speaker is at 1 o'clock on the channel that you can get on the agenda. Thank you.
Thank you so much. I'll see you guys on Friday to continue the lecture. Yeah. Okay. Thank you, guys. Bye.
Bye-bye. Your next lecture is on Friday, you said?
Yeah, it's on Friday noon. Yeah, it's not tomorrow, it's on Friday. Yeah, just want to make sure people follow the schedule. Yeah.
Okay. Is there a time that we could have an open house? Like I'm a teacher who's, a chemist. I'm not a computer programmer. It would be cool if we could have an open time at some point where we can ask our various questions, like at the very basic level as we play with it.
Yeah.
Because like I was trying really hard from my notes and from the materials that were done to upload a CSV yesterday, and it wasn't going well.
I think that's definitely.
Dr. Yang just answered it in like 2 seconds, and I'm like, there it is.
Yeah, I think that is a good suggestion. I think we can also talk with Dr. Chi Zhang, who is the organizer of all the lecture stream, to see what is the best way for us to for the question, whether we want to after go through all the lectures, right? We have an open house together to answer the questions from all the students from all the lectures for different instructors. All this do in another way, one lecture by one lecture. So yeah,
we just have a simple time where we have a simple task to do, and when we get stuck.
Yeah, I think this is definitely a good way. One thing is like one way is collect the questions from all students, so we can target all those questions in a systematic way. I think that would probably be a good way for us to solve the questions. We can set up a time to deal with that. I think that may be a good way for that. So what do you think? Yeah, because some students have some overlapped questions, so it might be good for us to synthesize all the questions into a more concise or more systematic way. So that is what I thought into my mind. Yeah,
I think because we have students at completely different levels. I mean, we've got some that have taken computer programming and all this, and we have others that really have very little experience. So they just need some in-person, like Zoom is fine, I'm calling that in-person, but they need some in-person time to just play with it and learn, when I do this, this is what happens. So the synthesized questions would help, but I think the other thing they need is just, here's a really simple task. As they get stuck on it, you're here, so they can say, I tried that, and you can say, you forgot a colon, or whatever, because some of the kids don't know how to look for that kind of thing.
Yeah, I think we have Peng Tao. Also, we have as a hands-on, I think, a lecture in the following strings. I think that would be helpful to interact with students to point out the specific questions they have. So here, for this lecture, I think we mainly talk about the concepts, how give students some intuitive how our program manager or different program language works. But in the following strings, we have hands-on lectures to specify, to interact with students to see, okay, how exactly work, why this work, why this not work. Yeah, I think Peng Tao here will help us to with the interaction with the students. Yeah.
Just thank you so much for your time. I appreciate it. I know.
Sure, no problem. We are glad here to be here. Yeah.
And I appreciate it greatly.
Any
Thank you so much.
Any question, just reach me, Dr. Chi Zhang. I think we're here to help. Yeah, hopefully kids can learn something during the summer. Yeah.
Okay. Thank you.
Thank you. Bye. Have a nice day.
Bye.